So the thing is that actually, because we know x2 has some impact on x1 and x3, so maybe we should fix the system or update the system before we try to do our second move. Okay? The idea is the following. Previously, when we have these two variables non-basic and this x3 and x4 basic, the things not so be too difficult. Why is that? Because at that moment, if you increase x1 or if you increase x2, it has some impact on x3 and x4. But because all your basic variables only appear in one column, all your basic variable only appear in one column. So you don't need to look at too much constraints. You just need to take a look at one constraint to consider the impact on that basic variable, because that basic variable does not appear in any other constraints. So the evaluation would be easy. Regarding the impact, if the basic variables does not appear in the zeroth row, you also don't need to consider how the non-basic variable would affect these basic ones. You just need to look at the coefficient and then you're done. Okay? So in other words, in summary, what we plan to do is that before we evaluate the impact of increasing x2 in the second move, we want to do something for the basic columns. We hope for basic variables, we have an identity matrix at the row 1 to row n, row m, okay, to row m. And also for the zeroth row, we hope it would be a zero vector. If that's the case, then all the things would be easily done. So going back to our original formulation, if we are having this system and we are talking about x1, which is 0068, for the basic columns, indeed we have the identity matrix and the zero column, the zero vector in the objective function. Okay, so now if x1 enters and x4 leaves, if x1 enters and x4 leaves, what we want to do is that we now should have a new basis, which is x1 and x3. So we need to update the system so that the system becomes some equivalent thing, such that for x1, it only appears in the second row, and for x3, it only appears in the first row. Well, how do you know that it should be x1 be the second row and x3 in the first row? Obviously, it is because your x3 is already occupying your first row. So your new entering variable x1 should only occupy the second row. There must be one row that is originally covered by an original basic variable. Now this basic variable would leave, a new basic variable should enter, so the newly added basic variable somewhat must occupy the row that was originally occupied by the leaving variable. Everything makes sense. So how may we somewhat do something on this system to make it this way? Well, elementary row operations, right? Because we have some equations, we want to get another set of equations that is equivalent to the original one without changing any solution, but getting forms in this way. That's row operations. So what we need to do is to removing all other values for x1 in x1's column. So all we need to do is to multiply the second constraint by 1/2. That's going to make this 2 becoming 1. And we need to change all other numbers, of course. And then we would try to eliminate this number, this x1 in your first row. So we would multiply the second row by -1, okay? And then add that into the zeroth row. Once we do that, your x1 would disappear, and there are some impact on the other variables. Finally, we may want to multiply the second constraint by 1, and add that into your zeros row. So here, when we are saying that you would like to multiply something by 1 or by -1, you really need to consider whether you are talking about the values before you multiply this by 1/2 or after you do that by 1/2. If you multiply 2 by 1/2, then this number actually becomes 1. This becomes 1/2, this becomes 1/2, this becomes 4, right? So once you do that, afterwards, when you want to eliminate that x1 in your first row, you multiply your second row by -1, okay? And once you do that, if you want to eliminate your x1 in the zeroth row, actually you should multiply that number by 2 instead of 1. Okay, but that's just some arithmetics, and that basically follows the principle of row operations. So after you do all these steps, your system becomes this one. Okay, and then updating the system would also gives us objective value where our new basic variables are 4 and 2, and our z2 would still be 8. So now let's take a look at how this new system would help us. We are looking at this new solution 4020, okay? So x1 and x3, they are basic, 4 and 2. z2 is 8, no problem. And now what we are doing is that one of x2 and x4 may enter. If x2 enters, we can see that this is negative, so z would go up. That's great. If x4 enters, however, that simply decrease your objective value z. That's bad. So very quickly we may see, oh, okay, so for x2, that's a good entering variable because the coefficient is negative. And once x2 enters, your row 1 says that it has some impact on your x3, right? For row 2, you know x2 has some impact on x1. And we all know how to do the calculations. All we need to do is to look at the entering column, 3/2 and 1/2, and the right hand side 2, 4. All you need to do is to do these ratios and pick the smaller ratios or the smallest ratios in general. When x2 goes up, x3 would become 0 sooner than x1. So it is x3 that would leave the basis. So your basic variables becomes x1 and x2 naturally, because x2 is entering and x3 is leaving. That's how it remains to be x1 and x2. Okay, so in particular, we are talking about the process. The idea is still the same. Having one to enter, having one to leave. It's just that if we want all the later evaluations can be easily obtained, then we need to fix the system to maintain an identity matrix for basic variables in the constraints and a zero vector for basic variables in the objective row. Once we are done with that, all the remaining things may be easily carried out.